Okay, logarithms are a new topic for you. Logarithms are a new topic. On your calculator, see if you can figure out how to type in the log of 100 and get your answer. See if you can figure out how on your calculator to type in log 100 and get your answer. Your answer should be 2. See if you can figure out how to do it on your calculator. If you're stuck, ask a neighbor, ask me. I want to make sure everybody can do log of 100 and get an answer of 2.
Calculator, check. I've got my calculator.
Good. Anybody have issues? Everybody get it?
Some shift.
Okay, awesome. So, let me show you a couple more answers to logarithms. And you'll be able to figure out what a logarithm is. Log of 1,000. Log of 1/10. Log of 10.
It's
It's kind of like the number of zeros. Yeah, I see that connection. Log of 100 has 2 zeros. 1,000 has 3 zeros. 10 has 1 0. I agree with that. This is really 1/10, right? The way you say that correctly is 1/10. So this one, I mean, doesn't really have any zeros, but I guess it does have a 0 in the denominator, right? It has 1 0 in the denominator. If you think about the fraction 1/10. What do you think logarithms are finding? Exponents that a 10 would need. 10 raised to what power equals 100? 2. 10 raised to what power equals 1,000? 3. 10 to the negative 1 power equals 1/10. Logarithms help you find exponents because logarithms are exponents.
I'll write that down.
Okay? I would write this down. Logarithms are exponents. Logarithms are really just exponents. You will use them to find the values of exponents that are variables. So logarithms are exponents. Now, the logarithms I showed you on the calculator all had a base of 10. Unfortunately, we don't always get to work in just simply a base of 10. So you will see other bases. For example, if you see this, log base 3 of 9, and that's how you say it, by the way. You can say log 9 with base 3, or log base 3 of 9. Don't say times or anything like that, because there's no multiplication here. Okay, this is just a value. It's not the multiplication of anything. So log base 3 of 9. When you see this, log base 3 of 9, it is referring to the exponent that a base of 3 would need to equal 9. So when you see this, log base 3 of 9, it's essentially going to find the exponent that the 3 would need to be raised to in order for it to equal 9. Now that's a simple one everybody can do in their head. What exponent would a 3 need to be raised to in order for it to equal 9?
3.
2.
I mean 2. Oh, 3 times 3.
Yep. 3 to the second power.
Stupid.
Okay? 3 would need to be raised to the second power in order for it to equal 9. Okay? So therefore, log base 3 of 9 is equal to 2. And the reason it's equal to 2 is because 3 needs to be raised to the second power in order to equal 9. That's always my first way of trying to describe to people what logarithms are. How are we feeling right now?
Yeah. Knowing that I know 3 times 3 is good.
Yes, yes. Okay? Don't write the rest of that stuff yet. If you have, I apologize.
I'm stupid.
I'll get it back up there, or something similar to it. So let me ask you a few mental math logarithms here. Okay? Don't need to write any of this down. I'm just going to ask you some mental math questions. Log base 5, 25. What's the answer? No. 2. It's 2 because 5 raised to what exponent equals 25? 2, right? So the answer is 2. You're thinking exponents now. Not multiplication, you're thinking exponents. There's another one. Log base 3, 27. 3. Because 3 to the third power. 3 times 3 times 3. How about log base 4 of 4? 1. Because 4 wouldn't have to be raised to the first power in order for it to equal 4. Log base 7 of 1. 0. Because 7 would need to be raised to the 0th power in order for it to equal 1. How we doing so far?
Few more.
Okay?
Getting this.
Log base 3 of 1/9.
Oh, would that be negative?
It would be negative 2. It would be negative 2.
Whoa. I think we're getting haunted.
Okay? Now, quick refresher on negative exponents.
Yeah.
Yeah? Okay? Here's how I explain negative exponents. I'll use 4. What's 4 to the first? 4 to the second? 4 to the third? Ooh, there you go, 64. So as my powers increase, my answers multiplied by 4, yeah? As my powers decrease, my answers are dividing by 4. So what's 4 to the 0th? 1. What's 4 to the negative 1? 1/4. 4 to the negative 2? 1/16. You see how they're basically the same, they're just fractions?
Yeah.
Okay? So that's why log base 3 of 1/9, if you know the answer's got to be a fraction, you know, the answer's a fraction, so the exponent probably has to be a negative number.
Yeah.
Okay?
That's what log means.
Log base 2 1/8.
3. Negative 3.
Negative 3. Because 2 to the third is 8. So 2 to the negative 3 is the reciprocal, or 1/8.
Easy.
Okay?
That's what log means.
How about that? Log base 9 of 3.
Let me just type this.
Wouldn't it be
Half. Half. When you raise something to the half power, it's actually like square rooting it. The square root of 9 is 3. 9 raised to the 1/2 power. 9 raised to the 1/2 power is like doing the square root of 9, which is 3. When you raise something to the 1/2 power, it's like square rooting it. When you raise something to the 1/3 power, it's like cube rooting it.
Maybe.
Yep. Maybe, kind of, sort of. All right.
Perhaps.
I'll try to make one real tough. And then I'll show you how we can use our calculators if we need to. Log base 1/2 of 16. One half to the sixth would equal 1/64.
Oh, it's gonna be -6.
That would equal positives. That would equal 64. That would equal 32.
-4.
There it is, -4. Yep.
Before you
Okay. All right. Now, you don't need to be able to do all of these mentally. That's totally fine. So I want to show you how to use your calculators to do this, okay? From the looks of everybody's calculator in here, none of you had a way to type in a different base, did you?
Yeah, I tried that.
Some of you did.
I kinda get it.
If you can, you will just be able to type in log base 1/2 16, press enter, get your answer. On this calculator, I can't type in different bases, so watch how I do it. Log of the big number, so that'll be log of 16, divided by log of the base, so the log of 1/2. Right? I have to take the log of the big number and divide it by the log of the base. So when I can't type in my own little base, again, I'm going to take the log of the big number and divide that by the log of the base.
Oh, I forgot.
Close your parentheses, yep. If you would like, write that down maybe in your notes so you remember what to do. Write this down in your notes so you remember how to do that on your calculator in case your calculator does not allow you to type in your own base. It's the log of the bigger number divided by the log of the base. So don't feel bad if you can't do these mentally. That's totally fine. No worries whatsoever. But I do want to make sure everybody knows how to use our calculator to get the answers. So far, recap. Logarithms are exponents. Logarithms are exponents. When you see a logarithm, it's asking you to find the exponent the base would need in order to equal that number. If you can't do it in your head, use your calculator. Everybody feels like they can use our calculator to get answers to these if they need to? Okay. Next. This equation right here and this equation right here are the exact same thing. They say the exact same thing. One of them is called logarithmic form. I'll just call it log form for short. And the other one is called exponential form. But they are the exact same equation. They say the same thing. One's in logarithmic form, one's in exponential form. You need to be able to change back and forth from one form to the other. And I'll show you why after I do a couple of examples. So, log to the base 4 of 16 is actually equal to what number? 2. And the reason why it's equal to 2 is because what? 4 squared equals 16. Alright, so numbers are going bye-bye. Log base b of y equals x. Change that to exponential form. b to the x power equals y. Here's how I remember. I start with my base. Good place to start usually is a base, right? You gotta have a strong base. Base raised to that number equals that number. Every time. 4 to the second, 16. 3 to the second equals 9. That's kind of my way to check to make sure I put it in exponential form correctly. The reason I'm showing you that is I'm going to give you this. 4 to the x equals m. Log base 4 of m equals x. You need to be able to change back and forth. Log form, exponent form, back to log form. Think. That little pattern right there. Yeah? Okay, one last thing. Why do we need to be able to change forms? Because we need to be able to solve every equation in the world. That's what we do in algebra. We solve every equation in the world, right? Okay? Take this equation. 2 raised to the x power equals 10. I need to know how to solve that. Well, I know my answer is probably somewhere between what two integers? 3 and 4. Because 2 to the third is 8. 2 to the fourth is 16. So my answer is somewhere between 3 and 4, but I'm not going to sit here and guess and check all these decimal places to figure it out. I'm going to change this from exponential form to this, and then I can use my calculator and actually get an answer. How would this read in log form?
Log x 2
Base 2.
10
Base 2
equals
Can you type log base 2 of 10 into your calculator? Or log of 10 divided by log of 2 and get an answer for x? Should be 3 point something. 3.32. That's rounded, obviously, to a couple decimal places.
3.3.
I got 3.95. Yours is rounding. Is yours rounding?
I'll check.
Should have a lot of decimal places, right?
Yeah, mine
Yeah.
does.
Log of 10 divided by log of 2. Should see a lot of decimal places. I'm going to have to look at your calculator. I don't know what's going on.
I think it's just calculator hashtag. Because if it's doing the same thing for Jackson,
Okay.
we need that.
But that's why we need logarithm, is to solve equations like this. We need to be able to solve for variables that are sitting up in the power. Okay? So, that's my intro on logarithms. I'm going to get you started on Khan Academy with some really simple practice, and I'm going to teach a bunch more about logarithms tomorrow. Stop the video.